The surface is already moving. At first, the cracks look simple. Long white fractures crossing a frozen moon. Old damage. Old pressure. Old history. Then the pattern starts refusing to stay where it appears.
On the surface,
fracture
Europa
shifts.
appears as a frozen wasteland.
Another
But
responds
beneath
somewhere
the
else.
crust lies a vast, hidden
The
ocean.
surface is showing evidence. The problem is that the evidence may not belong to the place where it appears. Europa's subsurface ocean is pressing beneath the ice. That changes the picture immediately. If the ice were only frozen crust, it should feel passive. Instead, the surface appears to react. The movement is not hidden in the ocean. The movement is written into the ice itself. For a moment, the view is simple. White terrain, long cracks, a frozen exterior. The ice is not still. A cut away from the bright surface to the dark water below creates a different interpretation. The fractures stop looking like scars. They begin to look like stress marks, not evidence of what happened long ago, but signs of something still working underneath. That matters because future missions may trust the surface
Projecting
first,
stress corridors across the
and if the
linear.
surface is already reacting,
Observational data
then the
now
safest
matching
looking
models.
layer on Europa may not be containing the danger at all. It may be revealing it. A section of ice shifts beside a dark fracture. By itself, that does not seem unusual anymore. The surface has already shown signs of strain. A crack moves, the ice responds, the pressure below leaves a mark above. Then another fracture shifts far away. Not beside the first one, not connected across the surface, somewhere distant, and it does not move in the same way or at the same time. For a moment, the scene becomes harder to organize. Nearby evidence should explain nearby behavior. A local crack should belong to a local problem, but the image refuses to stay local. Europa's subsurface ocean may connect every fracture. The view pulls back. White scars appear scattered across the moon. Beneath them sits a single dark ocean layer extending under the ice. Two separated fractures, one continuous body of water. One crack is not one answer. That realization changes the meaning of the surface. What looks like an isolated feature may belong to a much larger response moving through the ocean below. Europa moves through Jupiter's tidal pull, and the pattern suddenly looks cleaner. The moon is stretched, then compressed, stretched again, then compressed again. The motion repeats. Beneath the ice, the hidden ocean responds. In a simplified model, the water layer pulses with the same rhythm, rising and settling as the forcing continues. Europa's subsurface ocean is being flexed by Jupiter. For the first time, the movement begins to look organized rather than chaotic. A simulation overlays the surface. Predicted stress lines appear across the ice. Then the cracks are added. For a brief moment, they line up. Areas expected to shift show signs of shifting. Regions expected to carry stress appear to carry it. The match is not perfect, but it is close enough. For a moment, the pattern holds. That matters because people trust systems they can model. A hidden ocean connected across an entire moon feels far less threatening when its behavior follows a visible rhythm. The image becomes almost reassuring. Europa travels through Jupiter's tidal field. The ocean layer pulses beneath the ice. Surface movement follows the predicted pattern closely enough to make sense. Earlier instability, now seems easier to explain. The cracks no longer look like warnings from an unknown process. They look like the expected response of a world being repeatedly flexed by gravity.
Mission planning depends on that kind of confidence.
And that is exactly where the danger becomes harder to notice. Because the model does not have to be perfect to be trusted. It only has to work well enough. The simulation still looks convincing. Stress lines spread across the map. The predicted pattern wraps over the surface in smooth, organized paths. Everything appears to follow the same logic. Pressure below, response above. Then the real fractures are added. Some follow the expected pattern. Others do not. Several cut across the glowing prediction at angles that should not fit so neatly into the model. The mismatch survives. A mission could choose a landing site based on the model and still misunderstand what is happening beneath
Europa's
it.
surface is mapped with deep
Predicted
fracturing
lines
lines.
glow
New
beneath
models
fractures
show
that
these
refuse
cracks
to
only
align.
partially reflect the ocean below.
The view
As the
shifts below the
subsurface
surface.
model updated,
Pressure
magnetic
rises
and
through the
gravity
hidden ocean and
datasets
pushes
confirm
against the
liquid
shell
layer.
overhead.
Alert. Surface geology
Yet the shell does not
contradicts
behave
dynamic
like a
model.
clear window. It bends, it deforms, it changes the shape of what passes through it. Europa's subsurface ocean is distorted by the ice above it. That realization changes the role of the surface completely. The cracks may still contain information. The model may still contain real physics, but the connection between them is no longer straightforward. The signal arriving at the surface has already passed through a changing layer before anyone sees it. A mission could follow the correct model, collect the correct evidence, and still reach the wrong visual conclusion. Because the surface may not be showing the ocean directly. It may be showing a damaged translation of it. A bright shell closes over a dark ocean. The image looks secure. Frozen ice stretches across the entire surface. Beneath it, pressure moves through the hidden water below. Waves travel. Forces shift. The ocean keeps working against the underside of the shell. But it never fully breaks
Surface
through.
scan identifies thick,
That
static
is
ice
the
crust.
problem.
Receiving subsurface
The
sounding
ice was
data.
never just a cover.
Reclassifying structure as active
The same
reflective
barrier that
systems
protects the
stretch
ocean
across the
also
hemisphere.
conceals what the ocean is
Beneath the
doing.
ice, hidden structures are
Europa's
revealed.
subsurface ocean
Visible
turns
map
its
is
ice
incomplete.
into a warning. For a moment, the view remains still. White surface above, dark ocean below, pressure moving between them. Then the original fractures return. The long cracks that first appeared to be surface features now look different. They do not resemble simple damage. They resemble messages that arrived altered. The first cracks were not the mystery. They were the warning. An entire ocean exists beneath that ice, yet the behavior shaping the surface remains hidden inside the very system producing the evidence. That changes what Europa represents. The ocean is not simply beneath the moon. It is controlling how the moon can be interpreted. And that makes the danger larger than movement, pressure, or cracking ice. Humans may mistake limited evidence for reliable understanding. Because the most important part of Europa may be the part that can never be observed directly, only inferred through fractures that now look less like features on a frozen world and more like failed messages from below.